The whispers started about 3 months after the new team was hired. I'd hear them when I walked past the break room, when I was focused on my work and they thought I wasn't paying attention. Sometimes even in meetings when they thought they were being subtle. Martin takes forever to do anything. Why is he so slow? This should take 20 minutes, not 2 hours. We could get so much more done if we didn't have to wait for him all the time. I'm Martin Torres. I'm 47 years old. I've been the senior systems engineer at Apex Manufacturing for 16 years. I maintain the industrial control systems that run our production lines, the SCADA systems, the PLCs, the automation. Networks that keep $200 million worth of manufacturing equipment running 24 hours a day. The new team was 5 engineers in their late 20s and early 30s, hired 6 months ago as part of an operational efficiency initiative. They were fast. Really fast. They could write code quickly, implement changes rapidly, move through tasks at a pace that made my methodical approach look like I was working in slow motion. What they didn't understand, what nobody had bothered to explain to them, was that I wasn't slow. I was careful. And in industrial control systems, there's a difference that matters. When you're working with systems that control heavy machinery, where a wrong command can damage million-dollar equipment or injure people, you don't move fast. You move deliberately. You check everything twice. You test in isolation before deploying. You document every change. You verify, then verify again. The new team didn't know that because they'd never been trained on industrial systems. They came from software development backgrounds, web apps, cloud services, consumer tech. Fast-paced environments where move fast and break things is celebrated, and you can always roll back a bad update. Our environment wasn't like that. We couldn't roll back a command that sent a robotic arm into a safety barrier at full speed. We couldn't undo a configuration change that caused a conveyor system to run backwards while material was being loaded. We couldn't reboot a temperature control system that was mid-cycle on 3 million worth of aerospace components. But nobody had trained them on those differences. They'd been hired to modernize our systems and increase efficiency, which they interpreted as do everything faster. And I'd been labeled as the old guy who couldn't keep up. I'd tried to explain. Multiple times. In team meetings, in one-on-one conversations with our manager Dave Patterson, even in emails that laid out the specific risks of rushing changes in industrial environments. Dave's response was always some variation of, "Martin, I appreciate your experience, but we need to adapt to modern development practices. The new team brings fresh perspectives and efficiency gains we've needed for years." Fresh perspectives, efficiency gains, code words for you're outdated and slow. So I'd stopped trying to explain. I did my work the way I'd always done it, carefully, methodically, completely. I documented everything in our change management system. I tested thoroughly before implementation. I verified compatibility with the older equipment we still maintained. And I let them whisper about how slow I was. The crash happened on a Tuesday at 2:17 p.m. I was in the equipment room calibrating a sensor array when the alarms started. Not the regular warning chimes that indicate minor issues. The full plant emergency alarm, a sound that means something has gone catastrophically wrong. I ran to the control room. Production line 3 was completely stopped. Red status indicators across every station. The conveyor system was frozen. Mid-cycle with partially assembled components scattered across the line. The robotic assembly arms were locked in emergency stop position. Worse, the system wasn't responding to commands. The EMI screens showed error codes I'd never seen before. The control systems were effectively bricked. Dave was already in the control room, along with 3 of the new engineers, Kyle, Jessica, and Marcus. They were frantically clicking through screens, trying different commands, getting increasingly panicked as nothing worked. "What happened?" I asked. Kyle looked up, his face pale. "We pushed an update to the Line 3 control systems this morning. It was supposed to optimize the assembly sequence, reduce cycle time by 15%. Everything worked fine in testing." "Did you test on actual hardware, or in simulation?" "Simulation. We built a virtual environment that mirrored the system specs." My stomach dropped. "Which version of the PLC firmware did you spec the simulation against?" "The current version. 4.27. Line 3 runs on 3.8 Ta Fort Ryan. It's older equipment that can't be upgraded without a full hardware replacement." Kyle stared at me. "The documentation said 427. The documentation for lines 1, 2, 4, and 5. Line 3's documentation is in a separate folder because its systems are different. Did you check the equipment-specific docs? No. We didn't know there were multiple versions. Of course they didn't. Because they'd been moving fast, making changes quickly, not taking the time to understand the systems they were modifying. Jessica spoke up. Can we just roll back the update? Not easily. Industrial PLCs don't work like web servers. Once you've pushed a firmware-incompatible command set, you've corrupted the program memory. We'll need to restore from backup and manually reconfigure the entire control system. How long will that take? Dave asked. If we're lucky and the backup is clean? 4 to 6 hours. If there are complications, could be longer. Dave's face went pale. Line 3 was our highest volume production line. Every hour it was down cost roughly $85,000 in lost production, not counting the cost of scrapping the partially assembled components currently frozen on the line. Martin, I need you to fix this. Whatever it takes, I'll need access to the master backup archives and the original configuration files. And everyone else needs to leave the control room. No more changes, no more attempts to fix it. Just me. Dave looked at the new engineers. You heard him. Everyone out. Martin, you have whatever you need. For the next 7 hours I worked alone in the control room. First, I had to safely disconnect line 3 from the network to prevent the corrupted code from propagating to other systems. Then I accessed the backup archives, configurations I'd meticulously documented and saved every time we made authorized changes to the system. I found the last clean backup from 3 days earlier before the new team's update. I loaded it onto a test. LSC, I keep for exactly this purpose, verified it worked, then carefully pushed it to the production system. The control program loaded. The PLCs reinitialized. The HEM-I screens came back online. I ran diagnostic checks on every subsystem, verified sensor calibrations, tested each robotic arm in manual mode. At 9:43 p.m., I brought line 3 back online. The alarms cleared. The conveyor system started moving. The robotic arms resumed their program sequences. Production resumed. Dave had been checking in every hour. When the line restarted, he actually looked relieved. Martin, thank you. You saved us from a disaster. The disaster wouldn't have happened if the update had been done correctly. I know. We need to talk about that. Tomorrow morning. My office, 8 a.m. You and the new team. I went home that night exhausted, but I also felt something else. Vindication, maybe, or just the satisfaction of knowing that when everything broke, they'd needed the slow guy to fix it. The next morning's meeting was tense. Dave, me, and all 5 new engineers, Kyle, Jessica, Marcus, Nina, and Tom. Dave had clearly been up late doing math on how much the production stoppage had cost. Yesterday's incident cost us approximately $680,000 in lost production and scrapped materials, Dave started. That's unacceptable. I need to understand how we prevent this from happening again. Kyle spoke up first. We tested the update thoroughly in simulation. We followed all standard software development practices. This isn't software development, I interrupted. This is industrial control systems. Different rules, different risks, different processes. Martin, we understand you have experience with these systems, Nina said, her tone suggesting she thought experience was overrated. But modern development practices emphasize rapid iteration, and modern development practices will get someone killed in this environment, I said flatly. You pushed an update without checking equipment-specific documentation, without testing on actual hardware, without understanding the firmware limitations of legacy systems. In a web application, that's a bug that annoys users. Here, it shuts down production or worse. So, what are you suggesting? Marcus asked. That we go back to your slow, outdated methods? I'm suggesting that you learn why those methods exist before you dismiss them as outdated. Dave held up a hand. All right, everyone, calm down. Martin, you're right that we need to be more careful with industrial systems. But the new team is also right that we need to improve efficiency. How do we balance both? You train them, I said. Actually train them on industrial control systems, not just throw them at production equipment and hope they figure it out. You implement the change management processes that exist for a reason. And you stop measuring success by speed and start measuring it by reliability. Training takes time, Nina pointed out. So does recovering from catastrophic failures. You choose which time investment you prefer. Dave was quiet for a moment. Martin, what would comprehensive training look like? Minimum? 6 weeks of classroom and hands-on training, covering industrial control theory, our specific systems architecture, safety protocols, change management processes, and supervised implementation under my oversight. Then another 3 months of supervised independent work before they're cleared to make production changes without review. That's 9 months, Jessica said. We could implement dozens of efficiency improvements in 9 months. Or you could implement one more bad update and shut down the entire plant, I replied. Your choice. Dave made a decision. We're doing the training. Martin, you'll design the curriculum and run the program. New team, you're all enrolled starting next week. Until you complete training and Martin clears you, all production system changes go through him for review. The looks I got from the new team told me they weren't happy about this. But they also weren't arguing. Yesterday's failure had shaken their confidence. Over the next 6 weeks, I ran training sessions every afternoon. We started with the basics, the difference between its systems and operational technology. Systems, why industrial controls require different approaches, how PLCs work versus traditional computers. Then we got into the specifics. Our plant architecture, the different generations of equipment and their limitations. The safety systems that must never be modified without extensive review. The change management processes that seemed bureaucratic until you understood what they prevented. I made them work on the training PLCs I'd set. Isolated systems where they could make mistakes without consequences. I gave them scenarios. The temperature sensor on line 2 is reading 10 degrees high. How do you fix it? Then I watched them work through the problem, stopping them when they were about to make dangerous decisions. Kyle wanted to replace the sensor immediately without calibrating the system. I showed him what would happen if the new sensor had different characteristics. The control system would get inaccurate readings and potentially damage the heat treatment process. Nina wanted to update the PLC firmware to get access to better diagnostic features. I showed her the list of 5 other systems that would become incompatible if we upgraded, and the $200,000 cost of replacing all of them simultaneously. Marcus wanted to automate a manual safety check to save time. I walked him through what that manual check had caught in the past. Misaligned components, sensor failures, mechanical issues that automated systems wouldn't detect until something broke catastrophically. Slowly, they started to understand. Not all of them liked it. Nina especially continued to push back, arguing that we were being too conservative, that newer industries took more risks and innovated faster. Newer industries don't have 50-ton robotic arms moving at high speed next to human workers, I told her. When Facebook deploys a bad update, people get annoyed. When we deploy a bad update, people get hurt. That's the difference. By week 4, something shifted. Kyle was starting to ask questions that showed he understood the deeper issues. Martin, when we're testing changes, you always run the test cycle 3 times. Why 3 specifically? First run catches obvious problems. Second run catches intermittent issues that might not show up initially. Third run verifies that the first 2 runs weren't flukes. 3 is the minimum for statistical confidence in an industrial environment. That makes sense. I thought you were just being paranoid. I'm being appropriately paranoid. There's a difference. Jessica started reviewing equipment documentation before making recommendations. Tom began asking about change management procedures without being prompted. Even Nina started double-checking firmware compatibility. By week 6, they'd completed the classroom portion. I moved them to supervised hands-on work, real changes to real systems, but with me watching everything they did and having final approval before anything went to production. Their first supervised project was upgrading the diagnostic monitoring on line 4. It was a relatively simple change, adding sensors to catch early warning signs of mechanical wear. Low risk, high value. Kyle designed the sensor layout. Jessica wrote the PLC code to read and process the sensor data. Marcus handled the HMI screens that would display the diagnostics to operators. Nina designed the alert system that would notify maintenance when thresholds were exceeded. Tom documented everything for change management. They worked carefully, checked their work against equipment specs, tested on isolated systems before touching production, reviewed their changes with me at each stage. When they finally implemented it on line 4, it worked perfectly. First try. No issues. No production disruption. Just a clean upgrade that gave us better insight into equipment health. Congratulations, I told them afterward. That's what good industrial engineering looks like. Not fast, but right. It did take 3 weeks, Nina pointed out. But her tone had changed. Less defensive, more thoughtful. And how long did it take to recover from the line 3 crash? 7 hours of downtime, plus 3 days of reduced capacity while we verified everything was stable, plus $680,000 in losses. Right? So 3 weeks of careful work versus a crisis that cost us more in 1 day than a month of salaries. Still think we're being too slow? She shook her head. No. I get it now. Speed doesn't matter if you have to redo everything. 3 months into the training program, Dave called me into his office. Martin, I wanted to talk to you about the team's progress. They're doing well. Kyle and Jessica are ready for independent work with spot reviews. Marcus and Tom need another month. Nina's getting there but still occasionally wants to cut corners. I've noticed the change. They're asking better questions, making fewer mistakes. More importantly, they're not calling you too slow anymore. I hadn't realized Dave knew about that. The whispers stopped about 6 weeks ago. Because they finally understand what you've been doing. All along. You weren't too slow. You were doing it right, and they weren't trained well enough to recognize that. So why didn't you explain that to them when they first started? Dave looked uncomfortable. Honestly, I didn't fully understand it myself. I'm not an engineer. I manage engineers. When the new team complained you were slow and they could work faster, I believed them. I thought maybe you were stuck in old habits and needed to adapt. And now I understand that in some environments, speed is the enemy of reliability. I should have asked more questions before assuming they were right and you were wrong. I'm sorry. Apology accepted. But Dave, this is going to happen again. Not with this team, but the next time someone gets hired who doesn't understand industrial systems. How do we prevent it? What do you suggest? Formalize the training program. Make it mandatory for anyone working on production systems, not just new hires. Create clear certification requirements before people can make unsupervised changes. And maybe hire someone who actually understands OT systems to manage the team, not just someone who knows it management. Dave nodded slowly. That last point might be about replacing me. I'm not trying to get you fired. I'm trying to make sure we don't have another Line 3 incident. If that means bringing in someone with industrial systems experience to oversee operations, then yes, that's what I'm suggesting. You're right. Let me talk to senior leadership about restructuring the department. 6 months after the Line 3 crash, the engineering department looked very different. Dave had moved to a project management role, which suited his skills better. The new head of engineering was Patricia Mendez, who'd spent 20 years in automotive manufacturing managing control systems. Patricia's first action was formalizing my training program into a mandatory certification course. Her second was implementing tiered authorization levels. Junior engineers needed senior review for any production changes. Intermediate engineers could make certain changes independently. Only senior engineers could modify critical systems, critical systems, without oversight. Kyle, Jessica, and Marcus had all achieved intermediate certification. Tom was almost there. Nina had left the company after 3 months. She'd found a position at a software startup where move fast and break things was still valued. No hard feelings on either side. She was good at what she did, just not suited for industrial environments. We'd also hired 2 new engineers with industrial backgrounds. They didn't need the full training program. They already understood the principles. But they still went through our system-specific training and change management processes. Production incidents had dropped by 73% compared to the year before the new team arrived. Implementation speed had actually increased slightly because we weren't spending time recovering from failed changes. Equipment uptime was at a 5-year high. The whispers about me being too slow had been replaced by something else. People asking for my review before making changes. New engineers being told do it Martin's way when they suggested shortcuts. My methodology becoming the standard. One afternoon, Kyle stopped by my workstation. Martin, can I ask you something? Sure. When we first started here and people were calling you too slow, why didn't you defend yourself more? Why didn't you make a bigger deal about the risks we were taking? I did try to explain. Several times. But nobody wanted to hear it. You all thought I was just an old guy who couldn't keep up with modern practices. But you could have gone over Dave's head. Could have escalated to senior management. Could have documented the risks and protected yourself. If something went wrong. I did document everything. That's part of being methodical. But escalating would have made me the problem. The person who won't adapt, who blocks progress, who creates conflict. Better to let you learn from experience. Even if that experience was a $680,000 production failure, I would have preferred you learn without the failure. I tried to teach you before. But sometimes people need to fail before they're willing to learn. That's pretty patient. I'm not sure I'd have handled it that way. Being patient is part of being slow, I said. Everyone sees the deliberate work pace. They don't always see the deliberate approach to teaching, or dealing with conflict, or letting people figure things out. Well, for what it's worth, I'm sorry we called you too slow. You weren't slow. We were reckless. Apology accepted. And you're not reckless anymore, so we're good. A year after the Line 3 crash, I was presenting at an industrial automation conference. The session was titled, Speed versus Reliability, Why Methodical Beats Fast in Industrial Environments. Show of hands, I started. How many of you have been called too slow or too careful by colleagues who come from software backgrounds? About half the room raised their hands. These were all industrial control engineers, people who understood the field, but had faced the same challenges I had. Here's what I learned from being called too slow. Speed is only valuable if you're moving in the right direction. In industrial controls, moving fast in the wrong direction is catastrophic. Moving slow in the right direction is just responsible engineering. I clicked to a slide showing the Line 3 crash timeline. This was a production shutdown caused by an update pushed by engineers who valued speed over verification. 7 hours of downtime. $680,000 in losses. All because they moved fast without understanding what they were changing. Next slide, the recovery process. This was the fix. 7 hours of careful, methodical work by someone who understood the systems deeply enough to recover them safely. The same approach they'd called too slow was the only thing that saved us from even worse damage. Here's the point. Being methodical isn't being slow. It's being thorough. When people mock you for taking your time, what they're really saying is they don't understand the complexity of what you're doing. They see the time investment and not the disaster prevention. After the presentation, a young engineer approached me. Mr. Torres, I'm dealing with exactly what you described. I'm the only person at my company with industrial controls experience. Everyone else is from IT backgrounds. They keep pushing for faster changes and questioning why I'm so careful. How do I get them to understand? First, document everything. When you identify risks, put them in writing. When you prevent problems, note what you prevented and why. Build a record that shows the new value of your approach. That sounds defensive. It's protective. Not for ego, but because when something eventually goes wrong, and it will if they keep pushing for speed over safety, you need to be able to show you raise concerns. What if they don't listen until something breaks? Then, something breaks, and you're the person who knows how to fix it. That's when they learn. Not ideal, but sometimes necessary. And in the meantime, I just accept being called too slow. You accept that they don't understand what you're doing. Their perception of your speed doesn't change the quality of your work. Keep doing it right. Eventually, they'll either learn to appreciate it or learn the hard way why it matters. No. Years after the Line 3 crash, our plant won an industry award for operational excellence. The award specifically mentioned our methodical approach to system improvements that prioritizes reliability over rapid change. At the ceremony, Patricia Mendez gave the acceptance speech. This award reflects a culture shift in how we approach engineering. 2 years ago, we prioritized speed. We hired talented engineers and expected them to move fast. What we learned was that in industrial environments, the relationship between speed and quality is inverse. The faster you move, the more mistakes you make. And in our industry, mistakes are expensive. She gestured to me in the audience. Martin Torres, our senior systems engineer, taught us that lesson. Sometimes through patient explanation. Sometimes by being the only person who could recover from failures. But always by demonstrating that methodical, thorough work beats fast, careless work every time. After the ceremony, several of my colleagues from other companies came up to talk. Martin, how did you get your company to actually value careful engineering? Most places still worship speed, honestly. They had to learn the expensive way. I tried teaching them the cheap way, explanations, warnings, documented risks. That didn't work. Then they broke something costly and discovered that fixing it required the slow approach they'd been mocking. So you're saying we need to let our companies fail before they'll listen? I'm saying you can't force people to value something they don't understand. You can explain, document, warn. But ultimately, they'll either learn from your wisdom or learn from their mistakes. Your job is to be ready to help when they finally decide to learn. 3 years after the Line 3 crash, I was approached by Patricia. Martin, I want to talk to you about your career path. I'm not looking to change roles. I'm happy doing what I do. I know. But I'm worried about succession planning. You're 49 now. In 10 or 15 years when you retire, who's going to have your level of expertise? Who's going to be the person who understands these systems deeply enough to recover from catastrophic failures? Kyle's getting close. Jessica's solid on the newer systems. We've built a good team. They're good. But they're not you. They learned from you, but they haven't lived through 20 years of different scenarios and built the intuition that comes from experience. How do we replicate that? You don't. Experience takes time, but you can document it. I've been thinking about creating a detailed knowledge base, not just procedures, but case studies. Every problem I've solved, every failure I've recovered from, every lesson I've learned. Make it accessible so the next generation doesn't have to relearn everything from scratch. How long would that take? A comprehensive knowledge base? Probably 3 years of part-time work while I continue normal duties. Or we could bring in a technical writer and I could work with them to capture everything faster. Let's do the technical writer option. This is too valuable to delay. And Martin, thank you for sticking with us when people undervalued your work, for teaching the new team when they didn't think they needed teaching, for being right about what matters even when nobody wanted to hear it. If you've stayed with me through this entire story, I want you to understand something. This isn't about being vindicated or proving people wrong. It's about understanding that being called too slow often means you're doing something important that others don't value yet. When people whispered about me being too slow, they were measuring me against the wrong standard. They were measuring speed instead of reliability, immediate output instead of long-term stability, the time to make a change instead of the time saved by not having to fix mistakes. I wasn't slow. I was careful. And in industrial control systems, careful keeps people safe and equipment running. The Line 3 crash taught everyone that lesson the expensive way. But it was a lesson they needed to learn. Because speed without understanding is just recklessness in disguise. If you've ever been called too slow, too careful, too methodical by people who prioritize speed over quality, remember this. Being thorough isn't a weakness. It's a discipline. And when things break, and they will eventually break if people keep prioritizing speed over safety, the slow person becomes the essential person. Coin. If this resonates with you, hit that like button and subscribe. Share your experiences in the comments about times you've been undervalued for being careful, or times when your methodical approach saved the day. Those stories help others understand they're not alone. Remember, they mocked me as too slow. Then systems crashed and nobody else knew how to fix anything. Suddenly, I was the first call. And the whispers stopped.